Rain pooled in the ruts of a French farm track, turning the world into a patchwork of mud and standing water. Across it trundled a small, boxy vehicle that looked as if it had taken a wrong turn on its way to a boating lake. Its wheels churned through the muck. Its hull nudged the puddles aside, testing just how far it could go before physics objected. The army needed movement where roads failed, and the engineers answered with an amphibious curiosity. One machine, one modest engine, and a question that shaped an unexpected wartime niche. Germany entered the early 1940s with an uncomfortable truth. Mobility, the very principle that had carried its armies across borders, was being choked by landscapes that cared nothing for strategy. Roads collapsed under storms. Riverbanks dissolved into sludge. Bridges were blown, washed away, or never existed to begin with. In the east, entire kilometers of terrain offered nothing but swamp, channel, or snowmelt. In the west, France's twisting canals and low floodplains formed natural barricades. Here was the contradiction. The Reich demanded speed, yet its armies were being slowed by the oldest enemy of all, water. On paper, the Wehrmacht had a vast motor pool. In practice, it had an abundance of vehicles that stopped whenever the earth became soft underfoot. Conventional light cars bogged down after a few meters. The heavier trucks chewed themselves into the mud, until crews resorted to shovels and curses. The Germans required something else, something unconventional, a machine that could drive like a car, float like a boat, and transition between the two without theatre. Only then could reconnaissance patrols push far enough ahead to deliver the intelligence the High Command relied upon. The need emerged not from theoretical doctrine, but from field reports written under miserable conditions. Communications units stranded on waterlogged tracks, engineers unable to scout a crossing because the nearest bridge was kilometers away, or under fire infantry detachments forced to turn back simply because a ditch was too deep or too wide to ford. What commanders needed was what the terrain refused to give them: uninterrupted movement. Enter Ferdinand Porsche's challenge. The Volkswagen project, originally civilian, minimalistic, and intended for a peacetime motorization dream, was dragged into the mud of military necessity. From it came the Type 128, the predecessor to the Schwimmwagen. Longer, heavier, and more complex than the later Type 166, it was a proof of concept born from compromise. Its hull shape offered buoyancy but created manufacturing headaches. Its drivetrain handled transitions but groaned under excess weight. It moved across rivers, yes, but with all the enthusiasm of a man persuaded onto a damp rowing boat. Still, the Type 128 did something invaluable. It demonstrated that a light amphibious vehicle could work if refined. German engineers realized that bridging equipment could be reserved for armor, while nimble amphibious cars could handle scouting, messenger duties, and liaison tasks. This lightened logistical burdens and expanded operational reach. But the Type 128 lacked the agility and manufacturability required for mass deployment. By late 1941, intelligence reports highlighted riverine obstacles across multiple fronts. Even small waterways forced delays disproportionate to their size. Every pause risked exposure. Reconnaissance that arrived minutes late often might as well have not arrived at all. An amphibious car, cheap enough to produce in quantity, maneuverable enough for frontline patrols, and rugged enough for repeated abuse, became not just desirable, but essential. The request that trickled up through command channels was deceptively simple: build a smaller, stronger, faster amphibious vehicle, and do it quickly. Porsche's designers, already familiar with the constraints of the Volkswagen chassis, approached the task with a mixture of ambition and resignation. The concept promised elegance. The reality promised long nights, hot tools, and an engine that occasionally behaved like a clerk asked to work overtime. Thus emerged the demand for what would become the Type 166 Schwimmwagen, a compact amphibian shaped by necessity, sharpened by the failures of its predecessor, and destined to carve a peculiar niche into the technological landscape of the Second World War. The design logic behind the Schwimmwagen did not begin with grand speeches or sweeping doctrine. It began with quietly circulated memoranda, the sort written after field units listed their failures in plain terms. Mobility units reported that speed was irrelevant when a patrol stopped at the first flooded ditch. Reconnaissance officers demanded a vehicle that could slip across water without pausing to assemble pontoons. Engineering branches warned that bridge construction units already operated at breaking point. What the Army required was a solution that could be driven, not erected. From these mundane observations emerged a simple vision, a mobile scout car that treated water as just another surface, not a replacement for boats, nor a novelty for crossing rivers under ideal circumstances, but a machine that could wade through the messy, inconvenient, tactically awkward spaces that maps never represented honestly. Porsche's design team approached the problem with a disarming practicality. They knew the military wanted something lighter and more agile than the cumbersome Type 128. Their vision hinged on reducing weight without compromising buoyancy. This demanded a carefully shaped hull, not merely stamped sheet metal, but a form that distributed displacement across the vehicle's footprint. The hull needed to slip through water without creating excessive drag, yet remain strong enough to shrug off grounding on rocks or riverbanks. The task was not glamorous. It involved long discussions about panel curvature, thickness tolerances, engine placement, and wheel well intrusion. Every decision had consequences. A deeper hull improved flotation, but reduced ground clearance. A flatter hull improved road performance, but risked instability in choppy water. Every compromise carved the final silhouette of the Type 166. The engine, the modest air-cooled flat four inherited from the Volkswagen lineage, sat at the heart of these debates. It was simple, robust, and mechanically honest, but its output demanded mechanical sympathy. It delivered torque like an artisan handing over fragile pottery. Push it too hard, and it responded with the weary sigh of a man asked to carry one more suitcase up the stairs. Still, air cooling offered advantages. No radiator vulnerable to gunfire, no coolant to leak, and reliable operation regardless of water level. The designers also considered deployment doctrine. Reconnaissance patrols needed rapid transitions between land and water. The engineer's answer was an ingenious retractable propeller system. Folded up against the rear when driving, it swung down to engage directly with the engine via a clutch. No belts, no separate machinery, no delay. This immediate mechanical coupling allowed crews to glide from shoreline to river with no more preparation than easing off the throttle cabin layout, reflected the same pragmatic thinking. Seating was basic, storage limited, and controls positioned for ease rather than comfort. Military planners did not ask for refinement. They asked for predictability, serviceability, and the ability to keep moving after hours of punishment. The designers provided just enough space for crew, equipment, and the essential maintenance tools that seemed to follow every German vehicle into the field. Ergonomics were clearly drafted by someone who believed backs grew stronger through adversity. The final vision was not a masterpiece of luxury or excess. It was a compact amphibious scout shaped by frontline reports, engineered within the limits of existing Volkswagen components, and designed to function in the narrow gap between terrain and expectation. The Schwimmwagen's success would depend on whether this vision survived the uncompromising reality of wartime construction, a challenge awaiting in the next act. Production of the Schwimmwagen did not resemble the great industrial sagas of the war. No vast steelworks, no towering furnaces, no heroic silhouettes against blazing skylines. It unfolded in more modest surroundings, workshops where precision mattered more than spectacle. The Type 166 required shapes that ordinary automotive tooling could not produce, so its birth involved a blend of stamped panels, hand-guided forming, and careful assembly that pushed Volkswagen's manufacturing routines into unfamiliar territory. First came the hull. The engineering drawings, deceptively simple on paper, demanded tight tolerances along the lower body. Panels were pressed, trimmed, adjusted, and occasionally coaxed into place with the quiet insistence of a worker who had long accepted that metal never cooperated fully. This lower section formed the watertight base, and every weld carried significance. A bead laid a fraction too cold risked seepage. One laid too hot risked distortion. The welders developed a rhythm, short runs, controlled heat, deliberate progression, to avoid warping the curve that defined the Schwimmwagen's flotation. The upper body was more forgiving, though no less particular. Apertures for hatches, storage recesses, and the folding windscreen were cut with exactness. Internal reinforcement ribs were added to maintain rigidity, compensating for the absence of a traditional chassis. Because the Schwimmwagen relied on a monocoque-style structure, every junction served double duty, providing strength on land and resisting stress on water. The workers were not merely assembling parts, they were distributing load across a vehicle that had to behave like both a car and a boat. Attention then turned to the drivetrain. The familiar 1.1-litre air-cooled flat 4 was mounted high enough to avoid water ingress, yet low enough to maintain balance. Engine tolerances were checked with care, valve clearances, ignition gaps, carburetor settings. All had to be within spec, for the Amphibious unit demanded reliability. The engine, when first fired, often produced a sound somewhere between determination and complaint, like a man trying to start his day before his morning tea. The four-wheel drive system required notable precision. The transfer case, compact and cleverly packaged, allowed the front axle to engage when traction faltered. Its assembly demanded alignment checks that pushed the patience of mechanics who had to work with jigs not originally designed for such tasks. Driveshaft angles were measured, corrected, and occasionally revisited when an inspector raised an eyebrow. Then came the Schwimmwagen's defining party trick, the rear-mounted swing-down propeller assembly. It consisted of a simple mechanical pivot, a clutch engagement collar, and a propeller shaft aligned carefully with the crankshaft. Workers installed the system with the understanding that even slight misalignment would cause vibration. When set up correctly, the mechanism behaved with admirable civility. When not, it shook with the enthusiasm of a washing machine attempting escape. Interior fitting followed. Waterproofing compounds were applied around seams and cable entries. Seats were bolted directly to reinforced floor sections. Electrical components, minimal, functional, unadorned, were placed high to avoid moisture. Tools were stored in compartments arranged for accessibility rather than aesthetics. The entire cabin possessed an honesty that bordered on severity. Final inspection involved a water test. Vehicles were rolled down ramps into shallow ponds or basins. Workers checked for leaks, assessed trim, monitored propeller action, and listened for suspicious mechanical notes. Those that passed were dried, painted, stamped, and dispatched to units with an efficiency shaped more by wartime necessity than industrial poetry. The result was a compact machine built by hands accustomed to civilian Volkswagen assembly, but now applying precision for an entirely different purpose. The Schwimmwagen left the production line ready to confront terrain that would defeat ordinary vehicles, provided, of course, that the next phase of trials did not expose its flaws. Field testing did not take place in controlled laboratory stillness. It happened on riverbanks where the mud swallowed boots, on flooded meadows that clung to tires, and on water surfaces disturbed by wind, artillery rumble, or sheer misfortune. The Schwimmwagen's trials were pragmatic affairs. Operators climbed in, engines warmed, and the little vehicle was asked to do things that normal cars sensibly refused. The first sequence involved traction. Test drivers pushed the Type 166 across churned soil, angled slopes, and loose gravel. The lightweight hull offered advantages here. Weight distribution remained even, allowing the tires to bite rather than burrow. The four-wheel drive system engaged without fuss, pulling the vehicle up inclines that would stall heavier transports. Steering, however, revealed the machine's idiosyncrasies. At low speeds, the front end responded with the earnest wobble of a supermarket trolley that has opinions about your shopping route, though on stable ground it settled into a more predictable rhythm. Next came the amphibious transition. Approaching water required no ceremonial pause. Drivers eased forward, reduced speed, and allowed the bow to slip beneath the surface. As the wheels lost traction, the hull's displacement took over. The moment of flotation was subtle. A shift in resistance, a softening of feedback through the controls, propeller deployment followed. Lever down, collar engaged, engine revs stabilized. The movement from creep to glide was immediate, not graceful, but undeniably functional. In water, the Schwimmwagen behaved like a compromise between a dinghy and a determined terrier. Speed remained modest. The vehicle was never intended for elegant river crossings. What it offered was consistency. It tracked straight unless provoked by wind or current, and steering via the front wheels allowed competent operators to maintain direction without theatrical overcorrection. Crews quickly learned that throttle modulation mattered more than bravado. Too much input caused the bow to lift, too little allowed current to dictate progress. Data gathered from early river trials highlighted both strengths and vulnerabilities. Buoyancy margins were generous enough for crew and equipment, but left little tolerance for overloading a misplaced ammunition crate or poorly stowed tool roll could shift trim enough to alter handling. Propeller vibration, when present, revealed misalignment rather than fundamental design issues. Inspectors logged these as workshop faults, not engineering failures. Noise conducted through water provided another layer of insight. Operators noted how engine resonance carried across quiet rivers. A tactical consideration, reconnaissance units had to approach with care, leveraging terrain contours and background noise to mask their presence. Still, compared with the racket of larger craft or bridging operations, the Schwimmwagen's acoustic footprint was modest. On land again, endurance tests followed. Long-distance drives across mixed surfaces examined heat management, drivetrain resilience, and suspension behavior. The air-cooled engine demonstrated surprising stamina. Oil temperatures climbed but stabilized. Cylinder head heat remained within acceptable limits. The suspension, meanwhile, reacted to potholes with the theatrical indignation of a man discovering someone has moved his favorite armchair. Yet, it completed its tasks without structural complaint. One revealing test involved repeated entry and exit from water under time pressure. The Schwimmwagen excelled. Where conventional cars required recovery crews or boards to prevent sinking into mud, the amphibious hull allowed the Type 166 to skim across soft ground, pop free of suction, and continue without assistance. By the end of the testing cycle, verdicts circulated through engineering offices. The Schwimmwagen handled the unlikely combination of roles asked of it, not perfectly. No machine attempting two disciplines ever could, but reliably enough to matter. Field reports would soon determine where this amphibious scout would thrive and where its limitations would surface under the harsher conditions of wartime deployment. Deployment transformed the Schwimmwagen from a technical curiosity into a tool evaluated by people who had little patience for theory. Units wanted mobility, commanders wanted reach, and field conditions wanted to test every seam, weld, and hinge with relentless indifference. Here the Schwimmwagen experienced its moment of truth, a mixture of small triumphs and unavoidable limitations. Its breakthrough came in reconnaissance work. Light patrols, burdened with maps, radios, and too much uncertainty, discovered that the Type 166 allowed them to bypass predictable routes. Instead of searching for bridges or detours, they crossed irrigation ditches, narrow canals, and low rivers directly. This shortened travel distances and reduced exposure. Where a standard Kübelwagen might stall or sink into soft ground, the Schwimmwagen floated clear and carried on. The practical effect was subtle but significant. Intelligence arrived sooner and patrols returned more reliably, Artillery spotters also appreciated the vehicle's flexibility. On misty mornings, when riverbanks softened into sticky clay, the Schwimmwagen accessed vantage points other vehicles avoided. In several sectors, its presence allowed artillery batteries to adjust fire faster than Allied units expected. The machine was not glamorous, but it created momentary tactical windows that mattered. But limitations grew alongside these modest successes. The Schwimmwagen was never designed to endure the punishment of frontline combat. Armour was non-existent. The hull offered no protection beyond its sheet steel. Machine gun fire pierced it with ease, and shrapnel treated it with disdain. Crews learned to avoid exposed crossings unless conditions favoured concealment. A vehicle built to overcome terrain could do nothing against metal fragments tearing through the air. Mechanical endurance varied with maintenance discipline. Well-kept vehicles performed admirably. Poorly serviced ones revealed their weak points quickly: propeller hinges that developed play, seals that hardened under winter conditions, and ignition systems that disliked deep cold neglected Schwimmwagen started with the reluctant grumble of a man reminded he promised to help someone move house. Yet even then, it usually ran fuel consumption, while moderate presented challenges. Amphibious propulsion required revs, and revs required petrol. Extended water travel drained tanks faster than some units anticipated. Manuals cautioned against treating the Schwimmwagen as a ferry. Crews who ignored the advice soon found themselves paddling with rifle butts toward shore. The biggest operational failure came not from engineering, but from context. As the war shifted, the Wehrmacht's strategic situation deteriorated. Retreats forced units to abandon equipment frequently. Schwimmwagens were left behind when fuel ran low, when bridges collapsed behind retreating columns, or when rapid withdrawals left no time for recovery. Many survived the fighting not because they were robust, but because they were simply left untouched in backwaters, fields and barns. Leadership assessments reflected this mixed outcome. Some commanders praised the Schwimmwagen for granting reconnaissance teams new options. Others dismissed it as a luxury Germany could ill afford, a specialist tool in a war that increasingly demanded simplification. The truth lay between these extremes. It excelled when used intelligently and faltered when pressed beyond its design. The Schwimmwagen's performance was never going to reshape grand strategy, but in the small, granular spaces where war unfolded, in marshland patrols, river crossings and waterlogged approaches, it provided bursts of agility that conventional vehicles could not, and sometimes those bursts were enough to shift the tempo of a local engagement or preserve a patrol's survival. Its story now bent toward consequences Germany never fully anticipated, economic, industrial and symbolic, waiting to surface in the next act. Wartime engineering rarely ends where its designers expect. Once the Schwimmwagen entered widespread service, its influence began to spill into areas far beyond reconnaissance maps and riverbanks. Some consequences lay in industry, others in logistics, and some in the quiet bureaucratic corners where war's long shadows settled. This was the phase where the Amphibious Scout revealed its less obvious impact, a machine shaped by water that produced ripples of its own. The first consequence was industrial. Producing the Type 166 required Volkswagen to reconfigure sections of its manufacturing process. The monocoque hull demanded tooling unfamiliar to workers, accustomed to assembling Beetle derivatives. Welding talent had to be redistributed. Milling schedules were altered. Inspection regimes expanded. These shifts created bottlenecks that occasionally collided with the wider German demand for standardization. Factories strained to produce amphibious bodies at the same time they were expected to increase numbers of more conventional vehicles. The Schwimmwagen may have been compact, but each one absorbed skilled labor that might otherwise have gone to an armored unit, an artillery tractor, or a transport column. Material allocation offered another hidden cost. The hull's specific steel grades diverted supply from other programs' rubber use, minimal by comparison to tanks, but still present, carved a tiny notch out of already strained inventories. Fuel consumption, modest in isolation, increased when multiplied across thousands of vehicles. In a war fought across vast distances, these incremental burdens accumulated quietly. Then came the administrative impact. The Schwimmwagen introduced yet another vehicle type into an army, growing weary of its own complexity. Each new model demanded spare parts, maintenance manuals, dedicated mechanics, and supply chain adaptations. Storage depots struggled to track propeller assemblies and hull fittings. Training schools had to incorporate amphibious driving and recovery procedures. Instructors joked that the paperwork multiplied faster than the vehicles did, a phenomenon any soldier would confirm still occurs whenever a new machine is declared imminently straightforward. Post-war, the consequences shifted again. The amphibious concept lingered in institutional memory, even as Germany's wartime industry collapsed. Allied investigators studying Volkswagen's wartime production noted the technical elegance of the Schwimmwagen's simple propeller deployment, its clean drivetrain integration, and its watertight hull geometry. These observations influenced later amphibious designs in several nations, indirectly, quietly, but traceably through reports and engineering archives. In civilian life, the Schwimmwagen's aftershocks took a stranger path. A handful of vehicles, abandoned or captured, were repaired and used in remote European regions where waterways remained a daily obstacle. Farmers, surveyors, and municipal workers discovered unexpected utility in the machine's versatility. For them, it was neither a military asset nor a relic, just a practical contraption that crossed marshland without asking permission. A subtler consequence emerged in public memory. The machine became a symbol of wartime improvisation, not heroic like a tank, not grand like a bomber, but indicative of the small, precise adaptations armies make when confronted with uncooperative geography museums and collectors preserved surviving examples. But the Type 166 did not anchor itself to national mythology the way some wartime machines did. It occupied a quieter space, respected, examined, occasionally admired for its ingenuity, but seldom romanticized. Technicians studying surviving Schwimmwagens decades later noted another legacy, its craftsmanship. The welds, reinforcement ribs, and drivetrain mounts told a story of workers who balanced speed with care, even as wartime pressures intensified. Some restorers joked that the electrical system behaved like a 1950s radio that only picked up stations when it felt sociable, yet the fundamental engineering held firm through decades of neglect. Thus, the hidden consequences of the Schwimmwagen stretched far beyond its wartime patrols. It reshaped manufacturing workflows, burdened supply chains, influenced post-war experimentation, and left behind a modest but persistent legacy in the way engineers thought about amphibious mobility. A machine built to cross water had, in its quiet way, carved channels of influence that still flowed long after the war ended. When the guns finally fell silent, the Schwimmwagen found itself adrift in a world that no longer needed small amphibians to slip across contested rivers. Yet, survival has layers, and mechanical relics often find new ways to persist. The Type 166 entered its post-war chapter not with fanfare, but with the quiet endurance that had defined it from the beginning. At first, many were simply abandoned in fields, workshops, or barns, spoil of war left behind as armies retreated or surrendered. Allied forces collected some for evaluation. British engineers examined the hull form and applauded its simplicity. American testers appreciated the direct mechanical coupling of the propeller, noting how it avoided the belt-driven complications seen in other nations' designs. Soviet crews, never shy in their critiques, admired its utility while dismissing it as too delicate for Russian mud. Every nation saw something different in the same humble vehicle. As Europe rebuilt, the Schwimmwagen inherited unusual roles. Rural police departments in flood-prone regions acquired surviving units. Forestry services used them to reach remote riverbanks. Civil engineers tasked with inspecting drainage channels found the amphibious utility practical, if eccentric. A machine designed for reconnaissance became, in an unexpected twist, a tool for civil maintenance. Its second life was less dramatic, but quietly effective. Collectors entered the scene in the 1950s. To them, the Schwimmwagen represented a rare intersection of design quirks, neither car nor boat, yet undeniably both restorers found themselves wrestling with hull repairs, fabricating propeller brackets and tracking down original Volkswagen flat-fours. Starting one after decades of inactivity was described as similar to waking a hibernating badger, cautious optimism mixed with an understanding that teeth may become involved. Yet once revived, the machines demonstrated a sturdiness surprising for vehicles left to decay in outhouses and hedgerows. Museums incorporated the Type 166 into their collections, using it not as a symbol of conflict, but of engineering adaptation. A reminder that war often forces mechanization down unexpected tributaries. The Schwimmwagen's silhouette, squat bow, folding propeller arm, airy cabin, became instantly recognizable to enthusiasts. Its presence encouraged discussions about material shortages, field improvisation, and the German talent for coaxing multiple roles out of limited resources. In the broader automotive world, its influence lingered in unexpected corners. Amphibious car designers of the 1950s and 1960s, including the creators of civilian amphibious runabouts, cited the Type 166's simplicity. The concept of a direct propeller drive linked to an ordinary gearbox appeared in several post-war experiments. Even if these later vehicles pursued recreational markets rather than reconnaissance missions, the Schwimmwagen's engineering logic surfaced in their development notes. The vehicle's legacy also touched Volkswagen itself. Post-war engineers examining surviving examples rediscovered the advantages of tight packaging and air-cooled reliability. While the Beetle and later Transporter owed their success to different design priorities, the Schwimmwagen reminded the company that adaptability could be engineered into small footprints. In a sense, the Type 166 was an evolutionary branch that terminated abruptly, yet still fed nutrients into the larger tree. Today, surviving Schwimmwagens form a remarkably small population. Many are held by private collectors who maintain them with a mixture of affection and exasperation. Others reside in outdoor displays where rain beads off their hulls, just as it did decades before. Restoration workshops treat them as puzzles, decoding weld seams and reinforcing ribs with respect for the workers who once shaped them under pressure. Their afterlife is defined not by triumph or tragedy, but by persistence. Machines that once ferried soldiers through war now glide across quiet lakes during historical demonstrations, their propellers churning the water with unhurried confidence. And in these moments, the Schwimmwagen reveals the odd charm of a machine built for necessity, yet remembered for its ingenuity, a practical amphibian that managed to outlive the turmoil that birthed it. The Schwimmwagen's story circles back to the question posed in the open: how armies move when the world beneath them becomes unstable, liquid, or simply refuses to cooperate. The Type 166 existed not because it was elegant or ideal, but because the terrain demanded something unconventional. In that sense, it stands as a reminder that engineering rarely follows straight lines. More often, it meanders like a river searching for the path of least resistance. Viewed from a modern perspective, the Schwimmwagen occupies a strange niche. It is neither a technological marvel nor a historical footnote. It is instead a demonstration of what happens when practical constraints override ambition. Designers took a lightweight civilian car, reshaped it into an amphibian, and accepted results defined by compromise rather than purity. That honesty is part of its character. One might say it behaved like a civil servant asked to cover two jobs at once, willing enough, provided nobody expected it to excel at both simultaneously. Its engineering resolution lies in its duality. On land, the Type 166 was a competent, if modest, scout. In water, it was a steady, if unhurried, swimmer. The transitions between these modes were its true achievement. The effortless way it rolled into a river and simply kept going. This bridging of environments created opportunities that larger, more heavily engineered machines could not replicate. Its genius was modest, but genuine. Reflecting on the Schwimmwagen also reveals something about the nature of wartime innovation. Many machines of the era were defined by escalation: more armour, more firepower, more speed. The Type 166 pursued none of these. Instead, it embodied reduction, stripping complexity wherever possible, simplifying drivetrain, cooling, and transmission systems, integrating the propeller directly into the engine's output rather than creating a secondary system. It was an exercise in making do, in embracing limitations rather than defeating them. In a broader sense, the Schwimmwagen invites us to consider how technology interacts with environment. Every machine is shaped by the landscape it must navigate. In European battlefields, rivers and marshes were not theoretical obstacles. They were daily hindrances. The Schwimmwagen was, in essence, the physical acknowledgement of that reality. A machine designed not to dominate terrain, but to negotiate with it. Beyond its wartime purpose, the Type 166 offers a philosophical glimpse into design thinking. It shows that ingenuity thrives not only in grand inventions, but in humble adaptations. It reminds us that problem-solving often comes from reconfiguring what already exists, and it underscores a truth familiar to every engineer. Perfection is rarely attainable, but adequacy, thoughtfully applied, can be remarkably effective. Its final legacy is perhaps this: the Schwimmwagen was a bridge, not merely across water, but between eras of engineering. It connected pre-war simplicity with wartime improvisation. It demonstrated that light vehicles could serve roles traditionally reserved for heavier equipment, and it laid groundwork, however subtle, for later amphibious experiments that sought to refine the concept rather than abandon it. Today, when a surviving Schwimmwagen trundles into a lake during a demonstration, the moment feels less like nostalgia and more like continuity. The hull settles, the propeller deploys, the water parts, and the machine moves forward with the same steady confidence it displayed decades ago. The environment changes. The logic persists. In that quiet motion lies the true thought the Schwimmwagen leaves behind, that problem-solving is not always loud, dramatic, or heroic. Sometimes it is simply persistent, a small vehicle crossing a difficult boundary, reminding us that progress often begins with the willingness to get a little wet.